Hello everyone. In this video we're going to talk about how to get started with WEC Sim. So first of all we'll just talk about what is WEC Sim and what is the reference model 3. That's the example that we'll be using in this tutorial. Then we'll do some checks to make sure that WEC Sim's installed, and then we'll get into the tutorial, so running BEMIO, building the Simulink model, writing the WEC Sim input file, running WEC Sim, and then viewing some of the outputs from WEC Sim. So first of all, WEC Sim is the wave energy converter simulator, and it can simulate wave energy converters or WECs in a wide range of operational C states. It's all based on linear potential flow theory, so please make sure that you're familiar with the limitations of that method before you use WEC Sim. And it takes frequency domain hydrodynamic coefficients and BEM codes such as WAMET or Capitan as its main input. And then WEC Sim uses Cummins' equation to convert these frequency domain coefficients into time domain forces. And that enables us to model nonlinear constraints, subsystems, moorings, and so on. It's all developed in MATLAB Simulink, and it uses SimScape Multibody as the main solver. And SimScape Multibody is also where the libraries of constraints and bodies are contained. You can access the code on GitHub. We're at github.com/wecsim. So here's the reference model 3 or RM3. It's a two-body point absorber consisting of a float, which is the gold body in this diagram. That float is a torus shape, and it translates along the cylinder of the silver body, which also has this heave plate at the bottom of it. All of the files that you'll need to run this tutorial are available in the WEC Sim tutorials directory under the subdirectory RM3, and I'd recommend just copying and pasting that folder into a different location just to keep your WEC Sim repository clean. So first of all, let's check that you've got WEC Sim installed. To install it, all you have to do is download the WEC Sim repository and then run this script at the top directory. It's called add wecSimSource.m. Once you've run that, you can just enter path in the MATLAB command window, and you should see this list of directories, which are all the WEC Sim subdirectories. So once you've checked that all those subdirectories are on your path, then you're ready to run WEC Sim. So step one in this tutorial, we're going to run BEMIO. BEMIO's a tool that's included in WEC Sim that we use to read BEM coefficients, hydrodynamic coefficients from different BEM codes and convert them into a standard H5 format so that we ensure that we're always putting the same formatted hydrodynamic coefficients into WEC Sim. It's just because the different BEM codes have their own conventions, and we want to ensure that we know what we're putting into WEC Sim. So if you go to the rm3/hydrodata subdirectory, you should see this rm3.out file, which is a WAMET output file that contains all of the hydrodynamic coefficients in their raw format. And if you open up this other file, BEMIO.m, and run that in MATLAB, that should read the .out file, compute the impulse response functions, which might take a minute, and then save all the data to a .h5 file, which is what we read into WEC Sim. Some of the parameters for the impulse response functions are important. We don't need to get into them in this tutorial, but it's something to be aware of when you move on to your own models. You can just leave them as they are for now, but really, when we're thinking about the duration of the impulse response function, we just need to make sure that we give it enough time to converge on 0. That's really important for when we're doing the time domain simulations. Okay, so step 2, we're going to build the Simulink model. So if you open up rm3.slx, it should be a blank file, and you can start building the rm3 model here. So if you open up the library browser and scroll down to WEC Sim, you should see the WEC Sim subdirectories with the different elements. If you don't see anything in there, you can try refreshing the library browser, and that should bring them up. So first of all, you need to add some rigid body blocks that are going to represent the two bodies in this system. You can place two rigid body blocks into the SLX Simulink GUI. You'll need to rename these blocks. The first one should be called body 1, but you'll probably need to rename the second one to body 2. You might get this warning saying body doesn't exist, but just ignore that for now. We'll get onto that later. Once you've added the 2 rigid bodies, you'll need to add a global reference frame, and that's under the frame subdirectory in the Simulink library browser. And don't join these blocks up just yet, because we've got a couple more things to add. You can see them on this slide. So the next things we need to add are the floating 3 degree of freedom constraint block, which is basically ensuring that the system can only move in surge, heave and pitch. So we're ignoring yaw, roll and sway. And the translational PTO block from the PTO subdirectory is the joint that's going to attach these 2 bodies together and ensure that the torus is just translating along that cylinder. So a couple of points to be aware of. You notice B and F on these blocks. It's important to ensure that the B port, the base, is pointing towards the global reference frame, and the follower port is pointing away from it. So once you've added those blocks, you can join everything up and then hit save, and it'll resave the SLX file, and then you can close that window and we're ready to move on to the next step. So here now we're going to write the WEC Sim input file. You can open up this .m file from the folder. You should see quite a lot of information that's already there, but it's incomplete. So the idea of the tutorials is that we've left out some information for you to complete them yourself. If you do want to cheat and just get to the end, you could look at the same model in the examples folder, and that one should have everything that you need and it will just run. But if you want to work through the tutorials, you have to look at these variables that are listed on the right and add this information so that you've got the correct name for the SLX file, that you're defining the regular waves, you're defining the regular wave period and height, you've got the correct path to the H5 file, and then you've got some values for the PTO stiffness and damping as well. Once you've filled in all of that data, you're ready to run WEC Sim. So you can just type WEC Sim into the command window. You have to be in the RM3 directory in order for this to work. But hopefully it runs for you, and you should see the Simulink Simscape Mechanics Explorer pop up, and it'll look like the window that we see here, where you see the 3D rendering of the system moving on the screen. And you can control time in this GUI, rewind it, fast forward it, and so on. Once that's finished and everything's computed, some figures will pop up showing some of the data that we've generated. And as you can see here, we're just running regular waves. You can see the kinematic data and then the forces as well acting on the system. So that's everything to run through, everything you need to run through this RM3 tutorial. Please have a go, yeah, check out the pre-existing RM3 example in the examples directory if you can't get it working, because that one should have everything that you need. If you have any issues that persist, then please reach out to us on the WEC Sim GitHub issues board. That's our main point of contact. And yeah, happy WEC Simming.